Yes, it's me. Okay. So I would like to discuss with you today about three main topics. So the new EE architectures we already have seen, and the high-performance controllers and what EEs offer in this field. The second topic are non-functional aspects. So we heard a lot about functional safety, security, let's say cloudability and updatability. So there I would also like to give you a short introduction. The third topic I have is just a short insight, what we already started discussing. How can you handle the complexity of such a system? And also kind of hint I would like to give you there when it comes to OEMs. So let's start with the EE architecture. I think important is, even if we discussed the complete day about software, traditionally cars have been a hardware product. They are not a software product, let's say, this long. All the innovations are, for example, if you think about seats, power control, airbags, all of these functions were mainly developed in hardware departments, not longer in software departments. And this is dramatically changing. If you think about highly automated driving, connected cars, the complete car is connected. And it's not longer separate functions. If you think about the first ECUs, like mentioned from GE from Massimo, it was really separated. It was only Motorola, and it was complete separated infotainment system, or a radio. So low-end infotainment system, we would call it DIG. And the topic is, everybody has to be aware it's not changing the EE architecture. What is happening at the moment is changing the complete industry. High-performance controllers will change the Tier 1 supply networks, will change the OEMs, because it's no longer possible to be responsible only for one ECU, like the airbag. It's only in function. So be aware that the complete automotive industry and the supply industry is changing, not just the EE architecture. So if you think about today, the value of a car is still hardware. So you only have 5%. 5% roughly is content, 10% is software of the value of a car. Up to 2020, it will dramatically change. So the software value will increase. What you are willing to pay for software is increasing dramatically, and also the content. So this is changing, and we are more and more becoming to a software-driven EE architecture. We have done the first steps, if you think about the domain architecture, which are mainly, let's say, from electric perspective, it's already through. We're thinking about the next generation, and we're already working on the next generation, and this is high-performance controllers. So the next level, what we see is 2 to 5 high-performance ECUs, really with a lot of power. I think 10 DMIPs are too low. It will be more to 40 to 50 DMIPs per ECU in the future. We will have a clear decoupling of functions and ECUs. So at the moment, it's more the function is the ECU, and we will clearly see this is decoupling. And we will migrate different ECUs to one ECU within one HPC. Another topic, I added some slides which you're not seeing currently in your book, because I had a lot of discussions today, and I saw that service-oriented architecture, not everybody is aware about how it's working. And one of the main topics that we also see is that the service-oriented architecture is really replacing the CAN matrix, which is really static. And what we also see in the next generation is, at the moment, you have, like, depending from OEM, 4 to 20 access points. And we will get a central access point within one car. At the moment, for example, opening your key, you can hack your car with this ECU because it's an external access point. And we will really decrease the access points within the car. And also, of course, cloud and online services will come. So what we see on the left, what we should see? What we see on the left side is, let's say, the classical ECUs. We also have some domain or performance safety ECUs, like from an infotainment system, like in powertrain ECU, where, let's say, more and more ECUs are consolidated. We see different CAN buses, FlexRay, and maybe one Ethernet backbone. And the topic is here is really what the function is the ECU. And on the right side, we see the next level of the domain, so really high-performance ECUs. We see 4 high-performance ECUs, one for central functions, one for infotainment topics, one for highly automated driving. And the topic is, therefore, we really need service-oriented architecture. This is required. And the topic is, if you think about an EE architecture, it really looks nice on the right side. Clean, looks simple. On the left side, it really looks complex. But we're currently working already on a high-performance controller project with SOP next year. And I wanted just to give you a short insight about the complexity. Because, or maybe not, I don't want to give you insights. Here we go. So the current HPC we are working on has 4 processors running on it with 14 cores. So if you think about what we have on this one ECU running are 3, if I talk with our AUTOSAR guys, 4 operating systems, because it's a QM operating system from AUTOSAR, it's a safety operating system, so it's 2. And we also have running Linux on it, and we also have a security OS running. We have 4 different boot managers, and of course several virtual machines, because we have a hypervisor integrated. So if you think about complexity, and I think if you talk about complexity within the automotive industry or complexity overall, and it's common to talk about line of codes. So just to give you I should talk not about insights maybe, then it's not working. So what I wanted to show you how much line of codes we're currently estimating for the HCP with SOP next year. There we go. So also I would like to give you a short overview. Like a typical body controller you know today has like up to 2 million line of codes. And high-end navigation software has 4 million line of codes, and really high-end infotainment system has 10 million line of codes. We're currently talking about the HPC about 20 million line of codes. It's an estimation, could be let's say 10% more or less, because SOP is next year. But it's really a new level of complexity. So how does an architecture look for such a complex ECU? So we're running 2 projects. One is, let's say, non-safety critical that much, and another one is safety critical. So I'd like to share with you both. So what we have a high-performance computer. We have performance cores running there. On that, we have a hypervisor running, which is actually open source. So you can download it. It's a so-called L4V hypervisor. So you can download a hypervisor, use it, and on that we have different virtual machines. And the reason why we have different virtual machines is, on the one side, we're running adaptive AUTOSAR together with Linux. And here we really see, let's say, CPU-intensive functions, like sensor fusion, or different topics which are really running there. In the middle, we see let's say, non-dead critical, like an App Store, which is running there in the virtual machine. And at least in, let's say, in Europe and the US, you have a lot of classic AUTOSAR functions, and you would like to migrate it also to a high-performance ECU. Therefore, you have a virtual machine with a classic AUTOSAR solution running on it, so that you really can take over existing vehicle functions from classic AUTOSAR. What we also have is a secure boot, so a secure boot up and authentication running. I think everybody who knows ARM knows the trusted execution environment, so it's up and running there. And for some safety-relevant vehicle functions, we also have on the RF7, we have running in classic AUTOSAR to monitor the rest of the system. And you can also think about to make it, let's say, what we have heard today from Active, 1 out of 2 diagnostic system, so that you really can make it more safe, and also running in safety corner. So that is normally the end of topic 1. What I wanted to add, because I added some slides, is service-oriented communication. So we discussed and heard a lot about service-oriented communication, and what are the challenges and what are the options. So I added some slides, maybe not perfect, but I think it's important for everybody to understand. So it's more, at the moment it's more, let's say, configured and static. You know how the car behaves in every situation. Service-oriented architecture is more different. It's giving a public speech like I know, and everybody can actually choose if you would like to hear what I'm saying or not. If it's required to hear it or not. So it's more like like Alibaba or Craigslist. Somebody's offering somebody something, you can subscribe it or not. So it's really more in marketplace. So, because what is actually the problem, what not everybody is aware of, is static communication. The topic is, if you would like to add a new service. So, in the current car, like, I just used to open your smartphone because I heard it from you, that's one of the functions you maybe have to add. Then you also always have to change the gateway. So the gateway is always the point in the middle. So if you think I would like to add the function opening via a smartphone, I have to change not only the functions on one ECU, I also have to change the gateway. That is important to understand. And what is now the game changer with service-oriented communication? You have, on a different stages in the car, service discovery possibilities. So the car can decide on its own, okay, there's a function, open, close door, and you have to find out the matches. Do I need this service? Do I need to listen to this or not? So that is really the game changer about service-oriented architecture. Of course, it gives a lot of flexibility, adding no new functionality via OTR and other topics, but it's also adding a lot of more complexity. Because you also sometimes need more bandwidth to some peak times, and that is one of the challenges I think the complete industry is maybe still working on to bring it on an embedded device. So that's topic one. What is ED? What have we discussed about now? So the only thing we just discussed about the ED product portfolio is really the scalable software infrastructure. So we have heard in the morning from Thomas Scharnhorst that we have classic and adaptive AUTOSAR, and you can actually download it, but it's not, let's say, for series production. And what ED is one of the providers that you can buy classic and adaptive AUTOSAR and to go to series production and to have a solution there. The second topic we are offering is in Linux. So we have an automotive-grade Linux, and currently we are working on a Linux as a safety element out of context, and to have really a safe Linux, and we're also providing an Android solution. And of course we have some other departments like automated driving, user experience, and connected car. The second topic, because it's important to understand, is also the connected car, where I want to discuss with you is the so-called